Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, I want to go over exponential function transformation for Algebra 2 students. I just taped uh, another video yesterday. Well, basically, I usually tape them on the same day, but I post them on consecutive days, if you know what I mean. That's why uh, it will be posted today, or for you to be yesterday, and today I'm doing this one. Anyway, I already posted several videos on how to transform functions and do it in an easier way than the way presented in your books, which doesn't have rules like if you have translation and reflection, you have to do the reflection before you do the translation. And there is no such thing as you have to do something. Yeah, there are many ways of constructing these graphs, as I will show you, but it's much easier. It doesn't require a lot of if-then statements, so to speak. We agree, you already know that if I add, meaning or subtract, because you can add a negative value, a term that is referred to in transformation as translation, meaning you are not going to change the shape or the size of the graph. You are simply moving it right or left, up or down. That's it. So that's a translation. If you multiply, meaning multiply or divide, because you can multiply by a factor less than 1, which is division, basically technically, then multiply or divide by a term by a positive number, that means dilation. Again, I usually personally prefer not to use the word dilation, that gives the impression that something is larger, getting larger, while you can dilate with a factor less than 1. So I prefer, don't be worried, you can use dilation, but I don't like it. I'm going to say stretching if the factor is greater than 1, or shrinking if it's less than 1. Then if I multiply by -1, that's reflection, but it's done backwards, meaning if I multiply the x by -1, I'm reflecting about the y. If I multiply the y by -1, I'm reflecting about the x. And it makes sense if you think about it. If you change the x and make it, instead of positive y equals positive x is above, y equals negative x is below. So when you multiply the y by -1, it's reflecting about the x. Okay, here's an example. And if you watched my other videos of graph transformation, you know exactly what I'm going to do. If that's your first time, that's fine. I'm going to explain exactly what I do. First of all, I write the parent function. And the parent function, notice that all the numbers outside of the y and the x are just deleted. I delete the -2 and the 3 and the -4, and I say 2 to the x. That is my parent function. Parentheses with a function of x. Parentheses and a function of x. I don't want anything else. So I'm going to add 2 to both sides. Divide by 3 both sides. That's it. So I have y plus 2 over 3 equals 2 to the x minus 4. That's it. Now, if I wanted to construct the xy of the parent function, so this is the parent function, what do? I pick some values. So maybe -2, -1, 0, 1, 2. And if x is -2, I get a quarter. If it's -1, I get a half. If it's 0, I get 1, 2, 4, 8, and so on and so forth. Very easy. Now, let's do two things for the x and the y. Here is the x. The first thing I'm going to do, see what did I do mathematically? And how do I explain that in writing as a transformation? So all what I'm telling you is the only difference I see is between the exponent. This is x minus 4. How do I make this x? What operation do I need to make that x? And of course, you would say add 4, right? Because if I add 4, it becomes x. Think about it as I give you an equation. I say x minus 4 equals a number. Let's say equals 8. How would you solve? Don't you add 4 to both sides? So I'm going to add 4. Explaining that is to move 4 units to the right. Mathematically, I simply add 4. So 2, 3, 4, 5, 6, 7. Oh my God, I stopped at 6, 7. So they are going to make fun of me. Okay, how about the y? Y plus 2 over 3 equals 8. How do I solve for y? First thing you do, you multiply the y by 3. That's stretching the y by a factor of 3, right? Then I'm going to subtract 2 because now I have y plus 2 and in the parent function it was only y. So I have to subtract 2. Subtracting 2 from the y meaning moving down 2 units. So that's the explanation. I took the parent function, moved it 4 units to the right, stretched the y 3 times by factor of 3 and then moved the whole thing 2 units down. That's it. But how do I do that mathematically? Notice for the x, I simply added 4. For the y, I'm going to multiply by 3. 3/4 minus 2, so negative 1 1/4. Multiply by 3, 3/2. Subtract 2, negative 1/2. Multiply by 3, it's 3. Minus 2 is still 1. Multiply by 3 is 6. Minus 2 is 4. Multiply by 3 is 12. Minus 2 is 10. Multiply by 3 is 24. Minus 2 is 22. I'm done. Very simple algebra. Okay, now let's make sure this is correct. So I'm going to write this function. I'm going to say y equals, we said 3 times 2 raised to the x minus 4 minus 2. I can go to the window. My x starts from 0 to 8. That's fine. Negative, so negative something. So let's make y minimum is negative 1, for example, and y maximum is maybe 25 is enough. Graph it. Okay, now if I go to my table and I look at 2, I started x is 2, right? So at 2, I get negative 1.25. This is right. About 3, negative 1/2, 1, 4, 10, 22. I can plot it easily. I can explain what happened easily, and that's it. Now let's move to another more complicated example. Here is the function that I have. Of course, everybody knows now that the parent function is y equals 1/3 to the x, right? Now, in order to make that, I'm sorry. Maybe, well, it's not wrong. What I'm saying is that I should have added or subtracted something. So what did we do here? Subtracted 2, so let's add 4, whatever. Okay, so I want the right-hand side only to have 1/3 to the x plus 2, which means I'm going to subtract 4 from both sides. And then I'm going to divide by negative 2 equals 1/3 to the x plus 2. And again, like we did last time, here is my x and y. Notice it's 1/3. I can start also with negative 2, negative 1, 0, 1, 2, 3. If you don't know that 1/3 to the -2 is 9, if it's not easy, start with x equals 0, right? So that we know this is always going to be 1. Then multiply by 1/3, multiply by 1/3, multiply by 1/3, and then divide by 1/3, divide by 1/3, divide by 1/3, divide by 1/3, divide by 1/3. So it's easy to construct this. Now, like we did last time, let me start with maybe last time I wrote the x here and the y here, so it might confuse you because I have the y here, the x here. So let's do the x on this side. I have x plus 2. Now you know I subtract 2, meaning move 2 to the left. Mathematically, all what I have to do with the x is to subtract 2, nothing else. So -2 would become -4, -3, -2, -1, 0, 1. Doesn't take much. But what did I do here? Oh, notice I have multiplied by -2. I can multiply by -1, then by 2, or by 2, then -1. It doesn't matter. So for the y, I can say stretch by factor of 2 and then reflect on the x, or reflect on the x, then dilate or stretch by a factor of 2. It's the same thing, or do it simultaneously. Stretch y by a factor of 2 by 2, then reflect about the x. Basically, I didn't try it mathematically, so let's do it this way. Mathematically, you just multiply by -2, right? That's how you get rid of, oh my God, how you get rid of the denominator. Okay, multiply by -2. Then what do I do? Add 4, meaning +4, which means move up 4 units. That's what you write. Very simple. So I'm going to multiply the x by -2, then add 4. Multiply by -2 is -18, plus 4 is -14. Multiply by -2 is -6, plus 4 is -2. Multiply by -2 is -2, plus 4 is +2. By -2 is -2/3, plus 4 is 12/3. So -2/3 plus 12/3 is 10/3, or 3.33. By -2 is -2/9, plus 4, which is 36/9, is 34/9. What is 34 divided by 9? Did I ever tell you how to do these? It doesn't matter. Let's write it 34/9. But basically that equals 3. And then you get 7/9, right? When you multiply 3 by 9, you get 27, which is 7 away. So the remainder of 7. 7/9 is 0.777. You keep multiplying. 7 repeating. 1/27 times -2 is -2/27, and 4 is 108/27. So this is 106/27. Well, we can find this to be 3 point, and then 25/27. So it would be like 3.9 or something. Anyway, you can use your calculator, of course, and get it. Let's do that. Let's get out 106/27 is 3.925925. And we can show that mathematically, but anyway. Now let's clear the previous function and write the new one. -2 times 1/3 raised to the power of x plus 2 plus 4. Okay. The window, my x is probably from -5 to say 2 or 3. My y would be from -15 to 4. Yeah, here is my graph. And here is my table. Hopefully we did it right. When x is 1, 3.925. So this is right. How about when x is 0, 3.7778. When x is -1, I get 3.33, then I get 2, then I get -2, then I get -14. It's that simple. Just use algebra, regular algebra. How do I make this x subtract 2? How do I make that y multiply by -2 then add 4? How could it be any easier without saying, if you have dilation or you have stretching and you have this and you have that, you have to do this before that. In fact, maybe not here, but in other cases, I could have said, you know what? Instead of saying 1/3 to the x plus 2, I'm going to write it like that. I could have done the following. I could have multiplied 1/3 square, which is 1/9, times, I can write this as -2/9 times 1/3 to the x plus 4. It's the same thing. It is the same thing. Meaning if x is 1, if x is 0, you get 1, you get 4 minus 2/9 or 34/9, which is 34/9. It's the same equation. But now I can, don't do that at home, I mean at school, because you will get a 0. But I could have said 1/3 to the x, and this is y minus 4 divided by -2/9, meaning -9/2 times that. And I would have explained it differently. I would say, I'm not going to do anything to the x. What? No, the x has a 2. So no, I got rid of the 2. So now only the y will change. So I'm going to leave the x's as they are. For the y's, I'm going to divide by 9/2, meaning I'm going to shrink by a factor of 4.5 or multiply by 2/9 and then rotate or reflect on the x. Then I'm going to move everything up 4 units. That's it. There are many ways. Now I can visualize and see, oh, but can't I say 1/3 to the x times 1/3 square, which is 1/9? That's what I did here. So now I leave the x as it is. I'm not going to touch it. It's 1/3 to the x anyway. And then move everything to the y. Of course, that's not how it's explained in your books, so you may lose points. Don't use it. Play it safe. But what I wanted to say is that I can see it from different perspectives. I can do multiple transformations. I can just move one of the two and make that x plus 1 and make that -3/2, move x 1 unit to the left, and then use a different, you see what I'm saying? There are infinitely many ways you can do transformations and end up with the same graph, or explain a graph that is drawn to you, what transformations happen to it in many different ways, not necessarily this strict, rigid way. But that's the way you are going to use the strict, rigid way in this course. But I want you to start thinking that, oh, there are multiple ways of seeing the same thing from different perspectives, and all of them are correct. I hope this didn't confuse you. It simplified things for you, hopefully. If not, let me know. Or if you have any questions or comments, please don't hesitate to leave me a comment in the comment section, and I will get back to you as soon as I can. Thank you very much for watching. Wish you all the best. Hope to see you soon.